Lesson 1.2, Solving Multi-Step Equations. So our goal for this lesson is to take what we've been working on the last couple of days on one-step equations and understand how it all ties together when we're trying to solve an equation that involves multiple steps. So the first thing we're going to do is we're going to take a look at what we've done in class as far as discussing the roadmap technique and about undoing things. So take a look at these examples and see how they connect with what we've discussed in class. Alright, so like we discussed in class, what we're trying to do today is not only work on opposite operations instead of, subtracting 3, adding 3, or multiplying by 4, dividing by 4, but also realizing that what also has to happen in the opposite way is the order in which we work things out. Now, before we even get to that, let's talk about some stuff that should have come up last year, but it's probably been a while. That sometimes what we would like to do before we start actually doing the work is to simplify the problem, like in this case. Here I've got parentheses times 4, and this should look familiar from last year, which is this is distributive property. And so one thing that I would keep an eye on as you're doing all your work today is make sure that what you're working with is the most simplified version of the equation before getting to any work. So here, 4 times n becomes 4n, and 4 times 3, with the minus sign just dropping down, is 12. Alright, so now that I've cleaned it up a little bit, now I can start focusing on quote-unquote undoing things. I need to get rid of this minus 12, so at some point we're going to add 12. I have to get rid of this times 4, so at some point we're going to divide by 4. But in what order does that happen? Well, for that, what we have is the order of operations. When we used to do math problems, not equations, but just straight out math problems, we were told that these operations had to be done in a specific order, that anything in parentheses had to be dealt with first, then exponents, then multiplication and division, then addition and subtraction. So for us, not only are we supposed to do the opposite operations, we have to do them in the reverse order. And so that's where in class we discussed the whole roadmap concept. So let's take a look here at the same problem. What we want to do is we want to think to ourselves, well, how was this equation created? If this is the first time we'd seen this equation and somebody built it up from scratch using the order of operations, well, I need to list that out. So assume what happened here was that the only thing that they started out with was n, the variable that we're solving for. So over on my roadmap work, and this is where we're going to list things out, we're going to put n. And so according to order of operations, the first thing they would have done is any parentheses, which there are none. We took care of that earlier by simplifying. And then any exponents, but there's no exponents here. So next, according to the order of operations, multiplication and division would have happened next. So what would have happened is they would have taken n and multiplied by 4. So I'm just listing out the order of operations. So now I've got 4n, and it looks like the next thing they did was the last step in order of operations, which was to add and subtract. In this case, subtract 12. Alright, so now what I want to do is I want to put together the previous lessons that we've worked on, plus the idea that when we're trying to solve an equation, we're basically undoing the entire thing. In other words, we're trying to reverse all the work that was done. So what we do here on our roadmap is we pull a U-turn. Okay, and we reverse these directions that we were given. So since the last thing that they did to create this equation was subtract 12, our first move is to add 12. And so we're going to use the addition property of equality to add 12 to one side. What I do to one side of the equal sign, I do it to the other. These purposely cancel out. And here we get 28. Then I keep going reverse order. The first thing they did was to multiply by 4, so that's the last thing I'm going to do, which is to divide by 4. So divide by 4, divide by 4. So I get n equals 7. And if we go back to the original problem and check it out, 4 times 7 minus 12 equals 16. 28 minus 12 equals 16. 16 equals 16, and it checks out. Okay, so this is our big concept for today. This idea of writing out these directions so that not only are we keeping track of what opposites we're doing, but that we're also making sure we're pulling this U-turn and doing things in the opposite order as well. All right, let's take a look at a few more examples. Here's another one. So the first thing we want to do here is dissect how this equation was built up using the order of operations. So it looks like to me that they took x, and when it comes to a decision between division and addition, division's supposed to happen first, so that's the first thing I'm going to list. Then plus 4, because order of operations says parentheses exponents, multiplication, division, addition, subtraction. All right, so now I can pull my U-turn, and not only do I know that this plus 4, the opposite move is to subtract 4, I also know it's going to be the first thing I'm going to undo. So I'm going to subtract 4 from one side of the equal sign, subtract 4 from the other. These cancel. I get x divided by 3 equals 4. All right, then I look here. They divided by 3. I am going to do times by 3. So multiply this side by 3, multiply that side by 3. These cancel, and I get x equals 12. And if I took the time to check it, this would work out. I would get 8 for my answer. All right, let's keep going. More examples. Now here, once again, this is like the first one. Before you get into the actual solving, don't forget to simplify things. Right now you should be looking at this and thinking to yourself, that looks a little bit overly complicated. And I should be able to clean this up a little bit. In which case, I'm hoping you're thinking about something, again, from previous years, which is like terms. So what I could do is combine those. 2m plus 2m is actually 4m. And then I can just recopy the rest. 11 minus 5. Now I can start doing the work. This will be a little bit easier to do. All right, so to me it looks like they took m, and according to order of operations, they first multiplied it by 4, then subtracted 5. So I pull my U-turn. The first thing I'm going to do is to add 5. What I do to one side of the equal sign, I do it to the other. These cancel. I get 16 equals 4m. Here they multiplied by 4, so my move is to divide by 4. Once again, all the reverse moves in the reverse order. So divide by 4, m equals also 4. Okay, couple last ones. Now there's some tricks to these, so let's take a look. Now in this case, the reason why I chose this for our example is because there's something here that we've talked about before. We're solving for g, and according to order of operations, looks like the first thing they did to g was to multiply by 1/2. Then they added 5. So I pull a U-turn, and I do the opposite moves in the opposite order. They added 5, I'm going to subtract 5 from both sides. 1/2 g equals 4. Now, this is something we've talked about previously, but I want to bring it up again because we're going to see it more and more. Normally, the opposite of multiplying would be to divide. But we talked about in a previous lesson how when it comes to fractions, we don't actually divide, that at some point you learned that the move is actually to flip the fraction and multiply. And so once again, this is something that is always consistent when it comes to dividing with fractions, so you might as well just skip to that step. It's the only place where we have to learn a little extra rule when it comes to opposites, that the opposite of multiplying by a fraction is to multiply by its reciprocal. Alright, so over here, we're going to multiply by 2 over 1. What I do to one side, I do it to the other. Again, all this cancels out because it's just 2 times 1/2, which is 1, or 1g. And then over here, I get 8 over 1, and 8 over 1 is just 8. All right, let's take a look at one last problem, and let's just go through all the steps here. Now, once again, I chose this for a particular reason. This is a good, how should I say, a good situation where we want to clean things up first. It'll make our work with the roadmap a lot shorter, as opposed to trying to undo all this. So first thing I would notice here is that there's distributive property to be done. That 2 times all of this, we know that the distributive property says I can do this. Turn this into 2y plus 6. And then I also see some like terms here. Let's add those together. So I'm going to get 2y plus 12 equals 20. And now that I've cleaned it up, this looks a lot more like the problems we've been working on. And now I can look at it and do my roadmap. So the directions would be they took y, multiplied it by 2, added 12. So I'm going to pull my U-turn and do the reverse moves in the reverse order. So my first move is to subtract 12. Then to, oops, forgot to do it over here. When they multiplied by 2, I'm going to divide by 2. So over here, I'm going to divide by 2 on both sides, and y equals 4. Okay, so that's a little bit of work on solving multi-step equations. You'll work on this for your assignment today, and good luck with it. If you have any questions, make sure you ask your group or ask me.